Hello, in this video I'll show you how to program WebAssembly web application. As for example, we will use this simple implementation of Fizarum simulation. We will go through code and I'll show you how to program this in Rust. Then we will compile it into WebAssembly and launch in browser. Also, before we start, I suggest you to subscribe to my channel and set like if you like such videos. So what is Fizarum simulation? There is such organism, Fizarum polcephalum. Very interesting organism, you can find more information on the internet. And there are also such algorithm as Fizarum simulation, algorithm which result is similar to Fizarum polcephalum behavior. You can find many beautiful examples also on the internet. What we need to create it with WebAssembly? How the program will be constructed? It is a simple HTML file and JavaScript package produced by WasmPack program. To start with this, you need to install WasmPack. Also, you will need Python as we will use it for the server. So let's start programming. Let's start from creating two directories. First we name web server and second is created by this command. It creates a new Wasm Rust project. But first we go into web server directory. Here we create a main HTML file, index.html. Here we need some standard HTML code and we will define a few items here. Canvas is the most significant. After creating index.html, let's create simple server code so we can display it on the browser. Create a file named server.py. This is the server code. We need to send in headers to disable caching by web browser. However, I don't really know if it works. At first I tried to use this in Qt browser, but it didn't work. Requests to get new JavaScript and the WebAssembly package simply wasn't sent. But in Firefox it works. Also, this code was generated by ChatGPT. And now we need to launch server very simply by this command. Here is our result. Let's then continue index.html. Let's add some user interface elements that we will need in future. Here are one checkbox and three sliders and corresponding labels for them. Note that changing slider values also launches script to edit corresponding label in paragraph tag. Here is what we have got. Also, let's add some margin to right control panel. And here our result in action. Okay, now let's start to make Fizarum logic in Rust Wasm project. We already have lib.rs and utils.rs. Let's leave them as is and start to edit lib.rs. For first we will remove starting code. Here we need some modules. Also we need NullAlgebra crate and let's define some types based on NullAlgebra. To make the code work, we need to add corresponding crates into cargo.toml. Here is the commands. Also we need to add special features into cargo.toml. Future.js to get random and some features for WebSys to interact with Canvas and other elements. Then we need to define struct world. It contains chunks and some variables. What are chunks? The world is divided by square regions. We need to use them because pheromones with what agents interact are entities. To reduce number of unnecessary interactions, we will divide the world into chunks so agents interact with only pheromones which are close to corresponding agents. So let's define chunk structure and its input. They are very simple. As chunks contains agents and pheromones, let's define their structures and impulse. How physarom simulation works? We have agents and pheromone. Pheromone has wave. Agent has three sensors, which parameters are sensor angle, sensor range, and angle change. If a particular sensor have measured more wave than others, then agent rotates its velocity vector by corresponding angle. So let's add some hard-coded parameters for the simulation. Spawned agent's velocity, states of pheromones depending on time passed, and some other pheromone parameters. And also we need a num for agent behavior, what command will be applied depending on environment. Here are some helper functions that will be needed in future. So let's start creating impl of the world structure. We need to specify Wasm Bindgen to get it work on JS side. For first function new, here we will create the struct object. Note that by further implementation we need that sensor range is lesser or equal than half of chunk size. Important functions update and draw, we will come back to them later. Some functions to set internal state. And very important, spawn random agents. Let's implement it. It isn't too hard. We simply need to distribute number of agents on all the chunks. We will generate a few random numbers to set agents location and velocity. Let's then update draw function that will draw only agents for now. We need to get canvas and its context to D like in JavaScript is used to be. Then we need to clear the whole region and only then drawing. We draw agents like circles. You need to use arc and stroke canvas functions. My mistake, here we need to replace this code with calling of our helper functions. Let's move to index.html. Now we can add JavaScript code to show new results. For first, let's add this code. It creates our world object. Then we will spawn 700 agents. Also we need to resize canvas to proper size depending on number of chunks and their size. And we need a loop function that will be called once per 20 milliseconds. Okay, before we can show results, we need to compile our Wasm Rust project. Do this by this command. And also in web server directory we need to either copy pkg directory from physarom project or create a symlink. I create symlink in Linux via such command. Start the server and here is what we got so far. 700 agents are shown up. Let's continue on physarom lib.rs. We need to fill update function for first code to transfer agents between chunks when they pass to chunk border. You could explore code deeper by link in description. And then one another huge piece of code. Really it's not pretty, maybe I could use some other abstractions to describe what I want. But it's a trade-off. Either you need to figure out all the abstractions or you need to write some boilerplate but faster. I don't have a goal to create a fancy code for now, so I did this. And here a PS related to previous, applying commands to agents. And the last piece of code for this function. Moving agents, dropping pheromone. And don't forget to increment tick. Ah yes, see this function, we need to add it to pheromone info. It computes radius and weight based on our constants. Also, I didn't notice something. Rust C issued an error here. I didn't understand it fully, but okay. Let's start that simulation and see what happens. We can see the formation of distinctive patterns. And some more stuff. Let's draw the pheromone. Here is our final result. You can see that it's too computing expensive to draw such many circles, so simulation is slowed down. Let's finally add some features to index.html. We will add interaction for sliders and checkbox. Using add event listener, we add click handler to functions that edits internal world variables. And finally, we can interact with these variables, controlling agents' behavior. And here we got that result. Yes, this implementation isn't fast. There is definitely a proper way to do this using 2D buffer to store pheromone, as minimum rendering will be much faster. But for WebAssembly learning purposes, I think it's okay. Okay, so this is our result so far. You can download final application's code from link in description. Thank you for watching, don't forget to subscribe and set like, bye bye.